Ms. Smith here with a quick video on showing you how to solve a matrix. This is the system of equations we're going to be working with. Remembering a matrix is a way to solve a system of equations. It can have 3 variables, it can have 2. Regardless, you can use a matrix to solve either kind. So what we're going to do, we're going to take our coefficients that are in front of these variables, line them up into columns, and also take our constants and places into a matrix. Each of them form their own columns. So this is X, Y, Z, and our constants. What we're using to solve this problem, we're going to use an augmented matrix. This is what we call a coefficient matrix, but we're only using an augmented for this one. And incidentally, it is a 3 by 4 order. Our RC cola, R before C, rows before columns. Now, solving our matrix, we're going to use Gaussian elimination. If you've ever solved a system of equations, you probably have used elimination before. We're using that same concept, but we're going to be canceling out variables as we go, our coefficients. This is going to be our end result. We're going to have one with 1s and 0s here, but coefficients here. So I rewrote my matrix and gave myself some room to work. Also, I rearranged my rows. I want the 1 to be up here in this column. If I can get 1 at the top, I'm going to do it easy. And I did it. I placed the row that had the coefficient with the 1 in the front. I moved that up to the top of my matrix. Now, my goal is to get rid of this 2 and this 5 by completely canceling them out and making them zeros. How could I do that? I can do that. A positive 2 can be canceled out by a negative 2. A positive 5 can be canceled out by a negative 5. And since I have a 1 here, if I multiply negative 2 times 1 plus this 2, it'll cancel out and make that 0. So I'm going to do that. I'm going to do positive 2 plus negative 2 times 1. Now I'm also going to do that negative 2 times the number preceding it in the column or in the row preceding it for each one of these other variables. Now, since I have this and it'll end up canceling out to 0, I also want this to be a 0. And the only way to cancel out a positive 5 is to have a negative 5. And since I have that 1 right here, it works out perfectly. So I'm going to do the same thing here. I'm going to do negative 5 times 1. But then I also have to distribute that negative 5 to all the other variables in this row because they're part of the same equation. So I'm going to do the same thing. Now that I have my expression set up, I'm going to go ahead and evaluate them. I'm left with 1, 0, 0. Sorry, negative 10. So I got to put that negative 4. We have 1 plus negative 15, which will equal negative 14. 1. It'll be negative 3 plus a negative 2, which equals negative 5. And then negative 2 plus a negative 5 equals a negative 7. And then we have negative 1. Negative 3 plus a negative 2 equals, positive 2, which equals 5. And then we have negative 3, or positive 3 plus a negative 7, or 5. Plus 1, was that 3? Oh, actually, this should be a 2. There you go. So that would be 7. Matter of fact, would it be positive 7 or negative 7? Positive 7. All right. So now that we have those, we have a 1 in this column at the top, and we have zeros below it. So now we're going to get rid of this 10. The only way to get rid, or actually, we need that 10 to be a 1 if we can. And we can. We can divide a negative 10 by a negative 10, and that'll cancel out to all this to 1. Now, if we divide this by a negative 10, we have to divide all the numbers in that row by a negative 10. So let's go ahead and do that. All right, so once we divide all of these in this row by a negative 10, we're left with a 1 right here. And we have, of course, our 0, 0, and our 1 right here, which works out perfectly. Now I need this to cancel out to 0. The only way to get that to 0, negative 14 to 0, is to add 14. So I'm going to I'm going to add 14 times the number in the column or the row preceding that one. So this will be negative 14 plus 14 times 1. But I'm going to do the same thing to all numbers in this row. So now I've written all my expressions. Let's evaluate them. I end up with 1, 0, 0, as I started off with before. 3, 1. This is now 0. Now the third column, I have 1, 1/2. This is now also 0 because 14 times, of course, 1/2 equals 7. So I have 0. And then I have -1, -1/2. And this is also 0. I have a row full of zeros. I'm going to go ahead and stop right there. And then I'm going to go ahead and rewrite my equations with my variables. And then here for this bottom one, z is going to be equal to z. All right. So I'm going to take these now, and to find my solutions per se, I know 1 is already z. I need to rearrange this equation and solve it in terms of y. Then I rearrange this equation and solve it in terms of x. So rewriting the equation, I'm going to go ahead and move my z term over. I'm solving in terms of y first. And I'm left with y being equal to -1/2 z minus 1/2. All right, so we have the solution for y. We have our solution for z. Let's find our solution for x. So we're going to do 1x plus 3y plus. And I'm going to go ahead and rearrange this so that I'm going to plug in my given value that I solved for y here. And then I'm going to solve it in terms for x. Now I combine like terms. I have 3/2 c and plus a whole. That leaves me with, oh, hold up. That y had a negative right there in front. So this ends up being a negative 3/2z. And that leaves me with a negative 1/2 z. And now I'm going to move over my 3/2. That cancels out. I need a little bit more room. I got another sheet of paper. And this leaves me with 1x minus 1/2 z equals 1/2. I'm going to move over my z term. And I'm left with x being equal to 1/2 z plus 1/2. All right, and if I have to rewrite my solutions in order, I'm going to do 1/2 z, parenthesis, or comma, -1/2 z minus 1/2 plus, and then I have z. So that would be the solution to my matrix for this one. 1/2 z plus 1/2, -1/2 z minus 1/2 and z. All right. So that will be it for this video. See you next time.